Welcome to our webinar, Why Data Science Projects Fail. SenseCorp has been around for over 2 decades, offering a variety of consulting services across data, digital, and business transformation. Our team of skilled consultants offers insights and solutions to the most important problems facing business and government. Today, I have the pleasure of introducing our speaker, Gabby Leo. Gabby is a brilliant member of our data science team, offering expertise as a full-stack data scientist with proficiency in Python, R, and SQL, and exposure to big data processing tools such as Hadoop and Spark and AWS and Azure Databricks. From creating data pipelines to outputting real-time predictions and synthesizing her findings, her strength lies in helping clients implement successful data-driven projects. Thank you all for attending today's webinar. We're going to go ahead and get started. Gabby, the floor is yours.
Awesome. Thank you, Kelly. So good afternoon. I want to start off by thanking everyone again for joining us today. Like Kelly mentioned, my name is Gabby and I'm a data scientist with SenseCorp. My contact information is up there, so if you guys want to reach out, feel free to. But we've worked with multiple Fortune 500 companies, sharing and implementing our data-driven solutions. So I have plenty of scar tissue around why data science projects can be successful, but also why they can fail. So I'm really excited to be speaking with you all today on this topic. So let's go ahead and dive in. So just as an overview of what we'll be talking about today, we're first going to start with just, setting up why it is so important that data science projects are succeeding. So just going over the state of data science. Then we're going to dive into why data science projects are failing, covering 3 main pitfalls and giving you some solutions to these. And then lastly, make sure you guys stay on for the end part of this webinar. We're going to be doing an interactive part with the audience where we're going to be asking you some questions, and Kelly will help facilitate this, but your answers are going to be anonymous. All people are going to see is who, the percentages of what people voted for, the answers for each question. So make sure you guys stick around for this and interact, and you'll end up leaving with a project do's and don'ts checklist. So before we dive into why data science projects are failing, I really wanted to start with looking at the current state of data science and how rapid the adoption of AI is becoming across all industries and roles to better paint a picture of the importance of these projects succeeding. So if you guys are familiar with Anaconda and Kaggle, they released the state of data science, and in these articles, right, they have surveys that they've conducted to their community members, right? So this particular survey question was from the Anaconda state of data science. And I thought it painted a really interesting picture, right? Showing the types of different jobs held by data science learners. And you can see from the results that there's adoption across every role, right? So if you look at these roles and who's learning and applying data science, you see it's not just in the tech field, right? So in the tech field, we have software developers, data engineers, product managers, maybe data and business financial analysts. But outside of that, you have people in accounting and finance learning it. You have people in research and education learning it, as well as sales and marketing. So across every role, right, people are learning data science, right? So this is signaling that a revolution is happening, right? There's interest in data science spanning across a very broad range of job functions. So they're increasing their data literacy. So yeah, they may not be actually building the models out, but they're using them in their day-to-day job functions, right? They're hungry for machine learning. So if they're hungry for this and they're ready for this, right? Why isn't adoption spreading faster? Why is it so hard to get those models into production and implemented across every organization today, right? And the answer to that is that data science projects are failing at an alarming rate, right? So depending on who you ask, most industry surveys will cite that nearly 9 out of 10 data science projects fail. And we can attribute this failure to 3 specific reasons. So the first factor revolves around your data, right? Having your data in silos is going to prevent employees across the organization from accessing a set or source of data. If you have inaccurate data, that's going to lead to inaccurate decision making, and eventually that's going to affect your bottom line. And furthermore, if the speed at which your data is digested and made available to you is slow, real-time analytics is never going to be an option, right? So successful data science initiatives rely on aligning data quality, master data management, and data governance to ensure that all 3 are integrated and fully working together to make sure that we're preventing inaccurate, siloed, and slow data. The second factor that we're going to dive into is a lack of business readiness. So there's often a lack of an honest understanding of requirements and capabilities needed to take on data science initiatives. So we'll be touching more on the people and process side of business readiness by touching on how to set up your data science team within your organization and how other teams should be interacting with these data science teams. Then we're going to take a deep dive into defining achievable use cases that can be really easy wins for you and your team to get data science rolling across your organization. And then the last factor we're going to talk to attributing to why data science projects fail is centered around operationalization being unreachable. So in order to set your team up for success, your company should be investing in business modernization, specifically around making sure the technology stack is up to date and that your data pipelines and processes are scalable. There should also be a clear distinction between roles on the team where data scientists and data engineers are working together to create and push models into production. So throughout the first half of this webinar, we're going to be stepping through each of these in greater detail, giving you the solutions to prevent these common pitfalls from happening. So let's start with addressing the issue of data. So to better understand why clean data is so important, I'm going to be relating clean water to clean data throughout this section. So in our developed world, we've really taken clean water for granted, right? We simply have to turn the tap on, pour a glass, and drink the water. But if you think about how we got here, right, it hasn't always been that way, and it wasn't a simple process. We had to develop technology such as aqueducts, filters, and water treatment facilities to create and deliver that clean water. And now it is a standard, right? So why haven't we created the standard that our data should be clean? We continue to struggle with clean data because a lot of companies lack the required level of rigor and investment in processes, technologies, and resources to deliver it. And we know for a fact that dirty water can impact the health of people. So why don't we easily accept or recognize the impact that dirty data can have on an organization, right? So we understand, right, that we need clean data, but how are we going to get this clean data, right? So it's a process that begins with data governance, it incorporates data quality, and it leverages master data management. And most companies are only focusing on some or one of these efforts without coupling them together. But while water can freely roll downhill, data needs to be transported downstream, right? It requires a defined and a concentrated effort to end up with clean data. So ensuring that these three disciplines are aligned organizationally and that they're fully integrated and working together are going to be the key to success to getting your clean data. So let's start with that first concept of data governance, right? At SenseCorp, we define data governance as the exercise of authority and control, which includes planning, monitoring, and enforcement over the management of data assets, right? And here you see this diagram on the screen. This framework represents the various categories that must be considered in order to make any governance effort successful, right? So you have an organization that was set up with an identity and a purpose. Within that organization, you're making policies and procedures. Those policies and procedures are being driven out by tools and controls, and all of this is being communicated across your organization, and you have a funding strategy in place to do all this as well. So instead of jumping into each one of these sections specifically, I think the best way to understand governance is through a real life example of something that happened back in 1969 in Cleveland, Ohio. So for decades in the first half of the 20th century, industrial waste and sewage regularly poured into the Cuyahoga River, and residents accepted it as a consequence of the city's prosperity, right? They were booming, it was the industrial times, they just thought this was something that was going to happen and they were gonna have to live with, right? But in the 1960s, a lot of mindsets started to shift. The population became more environmentally conscious. So in the next decade, the citizens themselves demanded that there was governance over natural resources, right? So let's take a look at how they did this, right? So first off, there were decades of river fires that burned bridges, boats, and buildings along the shore. So then the citizens came and they demanded that change. So the Cleveland mayor, who acted as a voice of leadership, testified before the US Congress, right? And him doing this, right, this led to the formation of the Environmental Protections Agency, or the EPA, which in part led to the passage of the Clean Water Act. So that's a lot about water, right? Let's put our governance lens on, right? And let's see from a governance perspective what we did here for this water. So governing bodies were created with the authority to tackle the problem firstly, right? Then the Clean Water Act was passed, which was a statute that called for policies and standards. So you see that we have that organization set up. Now we have these policies and standards. Then the cleanup was funded through local bonds and federal money. So now we have the funding in place to actually drive this out. And if you think about the people, the agencies, and the controls that were put in place, this is exactly what governance looks like, right? So then go put your data glasses back on, right? These are the concepts that we need to transfer and apply to data today to ensure that our data lakes, our data rivers, our streams, they can stay clean and usable for everyone down the organization. And it's really important to note here that data governance is not just a project or a program. You don't just set it up and it's finished, right? It's a core business function that is necessary in order to compete in the 21st century business climate. You actually have to drive it out every day in your organization. And just as water needs to go through a comprehensive set of water quality checks before being consumed, data needs to go through data quality checks before being used. So there's 6 key dimensions in which data quality should be assessed. The first is completeness. Is all the data available? What about consistency? Can we match data across sources or data sets? We also need to look at uniqueness. Is there a single definition of that data? What about validity? Does the data match the rules? And let me give you an example for that one, right? You can't have someone in the system that's capturing your data whose age is 200, right? Logically, we know that's not possible in the real world. So why should something like that be allowed in your system, right? So these are rules that you should make up for the validity of your data. Then is there accuracy? Is the data correct? And lastly, we look at timeliness. Is the data available when needed, right? So all 6 of these coupled together make up the dimensions of your data quality. And your data quality is what leads you to understanding how clean or not clean your data is. And there's many different issues that contribute to the quality of your data, right? So some key contributors are source system issues, data input errors, redundant data, inconsistent usage, and lack of data auditing. And all of these can be improved upon with the policies and processes set forth in data governance. So you're starting to see how this is all interconnected, right? And furthermore, a lot of times today, you'll see that data quality is lumped in together with master data management. And that's because a lot of master data management technology offerings now provide data profiling and data quality tools inside of their offerings, right? But data quality indeed is considered a separate discipline than master data management. So I just want to touch on, what that difference is. So again, at Sense Corp, our definition of master data management is it's a technology-driven discipline that allows companies to accurately combine data from multiple data sources. It's used to create the master definition for data domains and to drive consistent use of high-integrity data across the company. A mouthful, right? So again, let's break that down with an example. So imagine all the different data sources used at your company to bring in data. You can have data from an ERP system, from a CRM system, and maybe even a claim system, right? All representing a single customer in 3 different systems. So with data being captured in different ways, there's inevitably going to be some differences. Maybe the person has recently moved, so their address in one system is different, right? Or maybe they have a nickname they go by, which they put in one system but not the other. So MDM would be the process of applying rules to determine the golden record to ensure alignment around the common use of data. And to bring it full circle, data quality and master data management can only be successful, again, when operating under a well-implemented data governance program. It's part of the business function, right? It's not just a process. So all this talk about data governance, but why do we care so much about data governance in the age of AI? And firstly, it's because it saves us time down the road. As a data scientist, when you're building a predictive model, we spend a lot of our time cleaning and identifying data to use or profiling our data. So imagine having clean data from the start, all accessible in one place, cataloged nicely and ready for you to use, right? So the time savings here would be tremendous. Secondly, we've all heard this before, but putting garbage into your model, you're gonna get garbage out of your model. So the worse the quality of the data that you train with, the worse the results of your AI. And honestly, AI projects shouldn't even be started until you know you have good data, as good data in leads to great decisions out. And lastly, a big topic in the AI community right now is creating trust with our models and practicing ethical AI. So with data governance in place, the privacy of your data being used in these models, along with the fairness of the model, can be assured, as data governance is going to help in the transparency around the collection, use, and storage of the data, as well as help in minimizing the bias in the data, because you can choose what's being circulated to those across the organization. So if there's one thing you take away from this section, overall, it's that bad data equals bad everything, right? It affects the bottom line and it affects your ability to make accurate decisions. And in fact, 88% of companies have reported that inaccurate data had a direct impact on their bottom line. And 42% of middle managers recognize that they have made decisions using the wrong data, right? So in order to make a case for clean data in the future, think about the 110-100 rule of clean data. At the point of capture, it's a $1 prevention cost to fix that dirty data, right? If you miss it at that point, it's going to go downstream, and that's going to balloon into a $10 correction cost, right? Again, if you don't catch it there and it keeps going downstream, then you're going to end up with, bad data when you're making that decision. So at the point of the decision, when you have bad data, that's $100 failure cost to your organization, right? So although it's a cheap cost upstream, downstream it compounds. So the moral of the story is put in the work upfront to make sure that your data is clean and accessible for all those in your organization. Okay. So now we are going to touch on the second point of why data science projects fail, which is a lack of business readiness. Whenever we think about a transformation, we think in terms of people, process, and technology within that transformation, right? And in this transformation towards AI, we're seeing that companies rarely lack the data, tools, or things that fit into that technology bucket. There's a plethora of data out there for them to use, and there's a lot of open source tools available to start analyzing your data. But what most organizations are lacking is centered around a people and a process domain. So correctly structuring a data science team within your organization is a huge step that needs to be taken by an analytics leader to enable a data-driven culture and help the company realize the full potential of their analytical capabilities. And what's even more interesting is that not only does setting up an organizational strategy for data science help secure a spot for data science to grow and flourish inside the organization, but it also helps the team surrounding the data science team and learning how to interact with them. So currently, right, data scientists have really desirable skills. They know how to program, they know how to visualize and analyze data, as well as build predictive and statistical models. Due to their knowledge across multiple domains, they're often getting pinged and pulled to put out fires, resulting in data science initiatives getting thrown to the back burner instead of working through a deliberate project scoped out by business teams. So in order to set up your data science team for success, we're going to take a look at 3 of the main types of strategies organizations are implementing for their teams. So we're going to start on one end of the spectrum, looking at the decentralized strategy. So this would be each area of business, right, within the organization is going to have their own analytics team dedicated to and embedded within their specific function. So think, sales versus product versus customer success versus finance, right? Each of those is going to have their own data science managers, their own data scientists, and their own data engineers. So the benefits of this are that it's really easy to build subject matter expertise within that area, and the analytics functions are going to be closely aligned with the business, the issues, and the customers, right? But some cons are that you're going to have to be moving and transforming data between units, right? And you're potentially going to be doing duplicated work if you're not communicating across those units. And you're working in more of a reactive manner, right? When they see a problem, then they're going to tackle it. It's not more of an innovative environment, right? And you'll normally see this arise in larger organizations where data science initiatives have arisen organically in multiple parts of the business. So that's the decentralized. Now let's jump to the other end of the spectrum and look at a centralized strategy. So this would be putting all your quantitative analysts, your data engineers, your data scientists, your data science managers, right? All of those would report into a central analytics hierarchy with responsibilities spanning the organization. So this is very common today in what you may have seen branded as a COE or a center of excellence. So this means that time and resources are managed within that specific unit, right? Not within the business units, to develop technical expertise and modeling capabilities as opposed to, being reactive to what the business units need. So it's a really proactive approach. The benefits are that you have shared services, processes, tools, data, methodologies, and you're being better positioned for long-term innovation, right? So centralized functions work really well in analytically mature organizations who have the time, patience, and money to fund what is essentially an internal research capability. The cons are that it does require a really large commitment and investment to empower fast and effective organizational adoption. And then building subject matter expertise with those data scientists and data engineers that are working across those different business units is going to take a lot more effort since they're not embedded within those teams. So if you're looking for a sweet spot or what falls in the middle, that's going to be the semi-centralized strategy. So like a centralized structure, you're going to have a single organizational data science leadership team, right? So they're not all going to be housed in one area, but at least the leadership team is going to be all aligned and in their own area. And the management team is going to serve, to hire, develop, and promote data scientists and data engineers. However, the data scientists are assigned to various business units and may focus on some of the same domain-specific problems to gain a little bit more knowledge in that area, but they can be rotated around, right, to gain knowledge across the business. So in short, the organization gets a centralized infrastructure, a common data science strategy, some effective talent management, and then the business also benefits because they're getting somewhat dedicated teams who are knowledgeable about their specific needs. Now, the key here is that, every organization is at a different part in their journey. So there's no right or wrong answer to setting up your data science organizational strategy. You just need to pick a strategy and educate those in the organization how to adopt to that strategy. And the other aspect that we're going to talk about that's folded into a lack of business readiness is making sure that you are defining achievable use cases for your data science teams. So this happens in 3 pretty simple steps. So firstly, you need to list out all the potential use cases. To me, this is the best part. This is really fun. There's no guidelines besides it just has to be a question that can be answered using data, right? It doesn't necessarily have to be a straightforward answer either. It can be that you're looking for an explanation or validation. And I want to caution you guys when you're thinking of these use cases and you're brainstorming to really steer away from things that only you think you know about or things that you may think are impossible, right? It should be a brainstorming session. You should throw everything out there and see what sticks. And it's really important to have multiple team members from a diverse background in these discussions instead of just people from one business unit or expertise, right? So once you decide and put out, everything out on paper, on the computer, whatever it may be, you list out those potential use cases. The next step is going to be evaluating each use case. And I'm going to show you a blown up example of this in the next slide, but that little graphic that you see down there, right? Imagine having an X and a Y axis. On the X axis, you have business value, right? And then on the y-axis, you have either the level of effort or the technical feasibility. So for this example, we're going to use technical feasibility. So a 0 for technical feasibility would mean that it's going to be really difficult to implement, and a 5 would mean that, it's really feasible, right? Like you guys you'll be able to pull this off with what you guys have right now. So what you would do is look at the use cases and then plot them on this graph to see where they fall according to business value and technical feasibility. So visualizing in this way makes it really easy to drive out our last step, which is prioritizing the use cases. So now you'll be able to clearly see which ones you should tackle first, which are those occupying the high technical feasibility with a high business value space. So those in the top right corner that we circled green, those were use cases that we drove out for our client first to give us a quick win, right? So when you think about enabling data science across the organization, it's better to start with something small that drives business value than to aim really high and fail. Then you're giving this perception across the organization that data science projects are risky, they take a long time to complete, and they aren't even successful. But by aiming for more attainable use cases, you're showing success to get the ball rolling. And all the while, don't forget that you're still developing your talent and investing in technology so that down the line in the future, you'll be ready to tackle the bigger ones highlighted in red. It's also really important to note that this isn't something that's static either, right? So as we talked about, you're investing in new technologies, your talent is growing. You can always choose to add more use cases, reevaluate, and reprioritize according to your current business climate. It's an ever-changing cycle that needs to be iterated upon. Okay, so that wraps it up for a lack of business readiness. And now we're going to dive into the last point, which is operationalization being unreachable. So I would say the number one factor contributing to making operationalization unreachable is centered around this idea of being able to identify that these two concepts, building machine learning versus scaling machine learning, are two very different sets of problems that each have their own sets of solutions, right? So this is playing a key role in why data science projects are failing. A lot of companies right now are building models, and this is a great place to start. But if you want your data science projects to be successful in the long term, integrated and implemented, across the organization into the business, you need to make sure that once they are built, that they can actually be scaled, right? And so let me give you a few examples of how these two problem sets differ, right? So think about when you're building a model, right? You're normally running this model on your local computer, maybe in a Jupyter notebook. But what happens when these models need to go into production and run in real time? Surely what you built on your local computer will break when scaled into production. Models in production should be running automatically, right? On your computer, you're doing it at a click of a button, but when they're in production, they're running automatically, and they're on a platform that has a lot of processing power, so they're not on your local computer. They should be checked regularly for model drift or to see if the model has become stale through an automated process, right? And these aren't even considerations you were thinking about when you were building your model. And also, when you were building your model, right, you weren't deploying anything. They were being run on command, and they were only being validated against other models manually, right? So you were just checking to see which model was the best. You weren't necessarily validating them to see if they had drifted or such. So creating and carrying out a plan to transition these models you built into production is really vital if you want this project to succeed. And this isn't the only arena that operationalization is composed of, right? There's a process side, a technology side, and a people side. So the process side is the one that deals with model deployment and model management. But in order to drive that out, you need to invest in the proper technology. So before we get into what specific technologies you should be investing in to keep that stack up to date, let's first take a step back and understand at a high level the big buckets that we need to think about in order to achieve operationalization from a technology standpoint. So storage is going to be that first bucket, right? Everyone knows the volume of data is growing on a compounding rate. So we need somewhere to store all this structured and unstructured data, preferably in a space that has room to grow. Secondly, we've touched on this at the beginning, so I'm not going to harp on it, but we need robust data, right? So we need to make sure that we have the proper processes in place to bring this data in from multiple systems across the business, even dating back to prior years, and making sure that all that data is readily available and easy for us to access. The next bucket is compute. When we're training models on millions of rows of data, it's no easy task for your computer. And when these models are running in production, you need them to be really fast, giving real-time results. So processing is going to be very important and should be a factor to be considered when thinking about technologies that you will be adopting. And then lastly, one that seems to get forgotten about sometimes, but that is just as important as the other three, is thinking about how you're going to present the output of your models, right? So when you're presenting this project to the stakeholders, are you going to be displaying a bunch of code to try to convince them that your model should be used to make decisions? Not likely, right? So you should be investing in a tool that can help you visualize your findings, as it's just as important as the other three buckets. So using those buckets that we just outlined, let's walk through the types of technologies that fit into each category. So for storage, you're going to want to invest in a data warehouse, right? Something that's highly scalable and in the cloud. You'll get on-demand pricing that's affordable for everyone, minimal setup time, and you don't have to worry about managing the database infrastructure. So example of these warehouses are tools like Amazon Redshift, Google BigQuery, Snowflake, or Azure Synapse. For achieving the concept of robust data, you're going to want to ensure that you have the proper data pipelines in place to bring your data to users across the organization in a timely manner. This powers your warehouses and is especially important when giving real-time predictions and analysis on streaming data. So some tools you could use in this space would be Apache Kafka, Airflow, Confluent, Spark, Python, and REST APIs. Once we have that data available to us for modeling, right, we need to actually build the models and use analytical tools and platforms to help us process all that data. So this is going to be the compute bucket, right? And these tools can even be looked at as a framework for the entire life cycle of a data science project. So these would be things like Python, R, Spark, Anaconda, Databricks, Alteryx, or Domino. And then lastly, what we touched on is how we want to communicate our findings, right? Using those visualization tools, because this is really what helps business stakeholders make those decisions. So you should be looking at things like Tableau, Power BI, Plotly, D3, and Matplotlib. And just to point out, this is not by any means an all-inclusive list, right? We know there's a lot of tools and technologies out there that we left out on here, right? But these are just some of the core main tools that we've used and that people use in their day-to-day to drive out these projects. Okay, so we've touched on the process and the technology aspects of operationalization, but what about the people, right? So I want to call out how important it is to make sure that your data scientists are working with your data engineering resources to achieve success. So as AI continues to evolve, as do the roles that come with implementing data science initiatives, right? And data engineering is being used to collect the relevant data and build pipelines to move and transform the data to make it available for the data science team. So this role sometimes can be filled by data scientists in a smaller organization, or in larger organizations, you may see a specific data engineering resource who has a software engineering background, or other times it's being fulfilled by the IT department, right? So the key here is that it doesn't matter who's fulfilling that data engineering role, but it is a separate role that needs to be filled. And data scientists, although they may still have to transform the data to fit it into their models, they're mainly analyzing the data using statistical methods to draw insights, leaving the data engineering to other resources who are more experienced in that arena. And so just to drive this point home, right, although they're distinct roles, the data engineering resources still must work closely with the data scientist to streamline those capabilities. So asking a data scientist to build a data pipeline is at the far edge of their skills. Meanwhile, it's the bread and butter of a data engineering resource, right? And data engineering resources can use their programming and system creation skills to create those big data pipelines, while data scientists use their more limited programming skills and apply their advanced math skills to create those advanced data products using those existing data pipelines that the engineers made for them. So the difference here really lies between creating and using, right, that data, and a team that expects their data scientists to be able to create those data pipelines might be disappointed. Okay, so overall, to summarize everything we just talked about, right? When you're seeing these issues arise in your organization, what are you going to do when you notice, that data is inaccurate, siloed, and slow? You're going to make sure that you're implementing data governance, which will enable data quality and master data management. If you realize that there's a lack of business readiness, you're going to create an organizational strategy for data science that works for your company, and you're going to prioritize those use cases iteratively. And lastly, when operationalization is unreachable, you're going to firstly realize and teach your organization that there's a difference between building and scaling machine learning models, that you need to update your technology stack, and you need to make sure that your data scientists are collaborating with your data engineering resources. So those are the three big key takeaways. And now we're going to move into the interactive part of this webinar, which again is surveying the audience. We're going to discover those projects' do's and don'ts, and you'll be leaving with a checklist. Again, one more time, it is anonymous. You guys are just going to see, like, in percentages what the responses were to the questions. So Kelly, do you have anything else to say here before we move into the 3 questions?
Nope, that's it.
Okay, awesome. So we'll give you guys about 10 seconds to answer each one. So first question is, when designing a solution, is your team more focused on designing the supreme solution or beginning on the solution early, being agile, and starting small?
All right, you should see the poll on your screen now. All right, I'm going, some people are still answering. Okay, we'll go ahead and end it.
Okay, that's great to see. So 100% said that they were beginning on the solution early, being agile, and starting small. Next question, what is the average timeline for deliverables on data science projects you have been a part of? Timelines that deliver on weekly scales or timelines that deliver on monthly scales?
Oh. This one has some more interesting results. All right, just a few more seconds.
Oh, cool, 50-50. Okay, that's good to see. And then last question. When engaging in a project, is your team hyper-focused on the business problem or hyper-focused on the solution?
All right.
All right, and we see about 70% saying hyper-focused on the business problem and about 30% saying hyper-focused on the solution. Okay, so good to see that we got some mixed answers there. I really appreciate you guys participating in that. Now we're just going to kind of go over the do's and the don'ts relating to, those were 3 questions that relate to the do's and don'ts, but we'll go through all of them. So 100% of y'all said you're beginning early, being agile and starting small. So that's really awesome to hear. That's what you should be doing, right? You don't want to think of designing the supreme solution all the time. This is kind of goes back to prioritizing those use cases, right? Make sure you're adding that business value. Then for timelines that deliver on a monthly or on weekly scales, it's going to be a lot easier to deliver on timelines that are in weekly scales instead of on monthly scales, right? When you're working on monthly scales, you tend to be developing in silos, right? Things are moving a little bit slower. You're not really constantly in communication with those stakeholders, and you might be just developing and then showing them something at the very end and might be having to go back and rework all of it. So you want to make sure that your timelines are delivering on weekly scales, and inside of those timelines, right, you're co-developing with the stakeholders and the SMEs instead of developing in silos. This one wasn't a question, but it kind of goes along with, designing the supreme solution. You should make sure that you're aiming for good enough and adding business value instead of trying to aim for perfect accuracy, right? You can spend a lot of time in trying to perfect your model, when in reality, you need to get that out to the business so that they can start using it. Again, you want to use more of a smaller team. It's going to be a little bit easier to deliver on those weekly skills if you have 4 to 6-person teams that are fast moving instead of large, slow moving teams. And then you're normally always going to end up with a better solution if you're hyper-focused on the business problem versus being hyper-focused on the solution, right? Being focused on the business problem will lead you to that solution. And then lastly, you're going to want to focus on the fast mover strategy instead of on the first mover strategy, right? It's really important in this field, in this industry, to make sure that you can ramp up really fast on any of the new technologies that are coming out. So you don't necessarily need to be the first one to develop it, right? But making sure that you're able to move fast enough and be able to learn that quick enough and start implementing it. So you guys will leave with this. And then I just want to give you guys a special sneak peek into our upcoming webinar, which is called Small Investments, Big Returns, 3 Successful Data Science Use Cases. And that's going to be on September 17th. So be on the lookout for that. It will be going over multiple client use cases where we have come in and helped them at a specific part in their journey or throughout their entire journey of AI adoption, right? And no journey is alike, and we're going to be describing or giving you use cases from clients from different industries. So the manufacturing industry, maybe oil and gas, maybe even education, right? So you definitely don't want to miss it. Again, I really appreciate y'all's time today. Thank you for joining us. I really look forward to connecting with you guys in the future. And if you have any questions, you can feel free to ask them now. Kelly will help facilitate them. Or again, you have my contact information, so you can feel free to reach out at any time as well. But thank you guys so much.
All right, thank you, Gabby. We did have a couple of questions come in during the webinar, so I can go ahead and start asking those while we see if anybody else adds to the list here. First, what are the different roles needed to carry out a data science project?
Great question. So, I mean, a lot of times it's going to, depend on what resources you have available to you. So I'll answer this from more of an ideal perspective, right? So you're always going to want to have a team lead, right? An analytics team lead who hopefully has subject matter expertise in that specific business area that this project is around. And then it's going to be really helpful if you could get, a cloud architect on that team who can kind of expand that system architecture to make sure that they're able to support operationalized analytics solutions. Then you're also going to want to have a data architect on the team, right? They own that data model. They define those best standards and practices. They'll understand the data the best for you to be able to ask those questions and figure out how you should be working with it. Then again, we touched on this, but you need both your data engineering and your data scientists, your data engineers to kind of build those structures, and then your data scientists to actually use the data and the pipelines that they've built. And then depending on if the project, has some reporting needs or whatnot, you might also be able to use a data analyst to kind of cover those visualizations and being able to communicate those findings. And then lastly, if we're putting this model into production, right, we're definitely going to need an integration developer. What system is it going to be on? How are people going to be interacting with it, right? You might need to build a custom app for it. You might need to integrate it into one of your current systems. So making sure that you have an integration developer on there would be very helpful. So I think those are kind of the main roles in an ideal role in an ideal world that you would want.
Great, thank you. One other here, in terms of MDM, how do you decide where to keep the master golden record? Do you choose one system to be the source of truth, or do you usually create something completely separate to be the reference point?
Good question. So normally it's a separate system or warehouse that is used after the data governance team has decided upon and created the rules surrounding MDM, right? But this is like the key to data governance, is the way that they're setting up these rules, right? So this is going to take away the power from each individual analyst on their own deciding, oh, how should I decide what the master record is, right? No, that's rules that you're going to make together with your data governance organization. It's putting a process in a place that's going to be standardized across the organization.
Okay, thank you. I don't see any other questions, but I actually have a question for you. Thank you so much for covering all of this. I was just wondering, in your experience, which of the pitfalls that you covered do you encounter the most when you're working with clients?
Yeah, so we encounter all of them a lot, right? That's why they're all on here. But I would say the one that is probably the biggest deal breaker is going to be within the operationalization is unreachable section, and specifically with understanding the difference between building and scaling machine learning models, right? So understanding that those are two like separate, completely different sets of problems that use different tools and processes. That's going to be the one that we see a lot. That's really the biggest pitfall and the hurdle from getting people from just building their models to actually putting them into production across the business.
Very interesting. Thank you so much. And we don't have any other questions, but like Gabby mentioned, if you think of something later or you're watching this webinar as a recording, please feel free to email us your questions to marketing@sensecorp.com. I want to thank you all for attending and remind you that you will be receiving a follow-up email with the webinar recording, the slides, and we will also include the registration for that webinar that Gabby mentioned. Thank you for joining and enjoy the rest of your day.